All right, let's distinguish real numbers. We've been talking about rational numbers, which are made up of integers, whole numbers, and natural numbers, and now we're going to talk more about irrational numbers. Now, irrational numbers can be written as a fraction, which in decimal form will either repeat or terminate. So rational numbers are like 1/2, -2/3. That one would repeat, that would terminate, 2.25, 0.3 with a hat over it. Your natural numbers, let's start with natural numbers though. Natural numbers are what you learn to count with when you're just a baby. 1, 2, 3, 4, all the way up. Your whole numbers are your natural numbers, but it also includes a 0. And then your integers are all your whole numbers, your natural numbers, and any negative numbers. And then your rational numbers are, of course, what we've already talked about. Irrational numbers are numbers that cannot be written as a fraction. And if you turn them into decimals, they will not repeat or terminate. Okay, so let's look and classify each of these. We'll take the square root of 12. Now, the thing about the square root of 12 is that if you take a square root of any perfect square, you're going to get a whole number back, and that would be rational, but 12's not on my list, so he's going to be irrational. But just to show you, if I put him into the calculator, I get 3.46410, da-da-da-da-da-da. That is not repeating or terminating, so he is irrational. Okay, negative 0.25 with a hat over the 2.5, it means 0.25, 2.25. So it's kind of one of these repeating ones. So he is just rational. All right. The negative square root of 9, well, that ends up being the -3. And -3 would be an integer number. And if he's an integer, then he is also going to be rational. So he has 2 classifications on that one. And then this cube root of 15, well, if you look at the cube root list, anything that would be in this list would be rational. But if it's not in this list, when we're doing the cube root, you're going to have irrational. So math, if I hit number 4, I get my cube root list pulled up, and then the cube root of 15 is 2.466212. You see there's not even a pattern there. So this one would be irrational. And then if you have pi, if I hit second pi, I get this number. It's not repeating, it's not terminating, so pi or any multiple times pi would be irrational.